Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the equivalent resistance for the circuit shown below. This is the circuit. We are going to find the equivalent resistance of this circuit, which means the total resistance. Now, you have to first analyze the circuit. When the current flows through here and comes to this point, it will divide into two. A portion of the current will enter here and a portion will enter here and comes out through here. So when that portion comes here, the portion that enters 3 ohms, when it comes here, it will also divide into two. The portion will enter here and come out. The portion will also enter here and come out. So you start from the end. You start analyzing the circuit from the end here. So when the current flows to all this when the current from this point that divides at this point, when it flows to 4 ohm, 5 ohm, and 3 ohm, the same amount of current enters to all these resistors. When it will flow here like this and come out through here. At this point, it will further divide again, but it will stop here. So the same amount of current flows through all these 3 resistors. That means they are in series. So you will say 4 ohm, 3 ohm, and 5 ohm are in series. So now the equivalent resistance of these 3 resistors will become resistors that are in series, you add them. So in my last 2 videos, I discussed how to find the equivalent resistance of resistors in series and in parallel. So the link of the 2 videos are in the description below. You can watch those videos to have a better understanding of how to solve this question. So you add them since they are in series. Plus 3 plus 5. No, 4 plus 3 plus 5. So this is 12 ohms. So the first equivalent resistance here is 12 ohms. So we will draw this circuit. So these 3 resistors, the equivalent resistance is 12 ohm. So it's now one resistor like this. So this one. So these 2 are here. And this 6 ohm is this. There's a 3 ohm attached. Then this 4 ohm, this is it here. Then these 3 now, the equivalent resistance is 12 ohms. So it's now one resistor. Like this. That's all. Now here is 12. Here is 4 ohms. Here is 3 ohms. Here is 6 ohms. Here is 4. Here is 3. So we continue. Now, when the current flows here again, it will divide at this junction. It will also divide at this junction. So that means this and different when it comes here, different it will split into two here. So these two will receive a different amount of current. So that means they are both parallel. They are both parallel to each other. So now it will be 4 ohm parallel to 12 ohm. So now there's a shortcut to find the equivalent resistance of two resistors in parallel. So the shortcut is product over sum. So you find the product over the sum. Here is 46. No, 48. 4 times 12 is 48. 48 over 16. Okay, divided by 16 is 3. So 48 over 16 is 3 ohms. So the equivalent of these two is 3 ohms. We will withdraw the circuit. So the equivalent is this. This is 3 ohms. So this one and this one is 4 and 3 ohms. Then this one is 6 ohms. This one is 3 ohms. So again, when the current enters here and splits at this point, the portion will enter here and come out, and that portion will enter here and come out. Since the same amount of current is entering through 3 ohm and 3 ohm resistor, that means they are in series. They are both in series. So we just go straight to the point and add them. 3 plus 3, which is equal to 6 ohms. These two are in series. So we draw the circuit. Here is 4 ohms, here is 3 ohms, here is 6 ohms, and here is 6 ohms. So now in the same way, when the current flows through here, at this point, it will divide. Some will enter here, some will enter here. So since at this point, the current will split, part of it will enter here, and part of it will enter here. At this point, so when the current flows through this circuit, a portion of the current enters 6 ohm resistor here and comes out, and that portion enters the other 6 ohm resistor and comes out. So that means 6 ohm and 6 ohm resistor are parallel to each other. So find the equivalent resistance. It is simply product over sum. It will be 6 times 6 over 6 plus 6. And remember that this method is only applicable to 2 resistors in parallel. When it is 3 and above, you cannot use this method. So this becomes 36 over 12. 36 divided by 12 is 3 ohms. And then finally, I'll withdraw the circuit. So these 2 resistors, the equivalent resistance is 3 ohms. So here is 4 ohm. Here is 3 ohms. And here is also 3 ohm. So now the final equivalent resistance of this whole circuit is given by this summation. Since the current will enter here, it will the same amount to flow through 4 ohm, 3 ohm, and 3 ohm. So all these resistors are in series. In other words, they are placed end to end. So you just find their sum to find the equivalent resistance. So it will be 4 plus 3 plus 3, which becomes 10 ohms. So the equivalent resistance of this circuit is 10 ohms. And the final reduced circuit of this complex circuit is this. So and the final equivalent resistance, or in other words, the equivalent resistance of the whole circuit is 10 ohms. Hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.